Hey, hi friends, very good morning to everyone. Last class we are seeing about what is data guard and different types of modes that we have in Oracle data guard environment. So, yesterday we talked about maximum performance mode, sorry, so in which we tried to understand how exactly the standby database is going to work and why it is called as max performance mode. So because primary database is not going to worry about the standby database, so it is the reason the primary database will just behave like a regular database without impacting the performance. So that's why that particular mode is called as maximum performance. So this, and we were discussing about a situation what happens if there is a archive log gap and the primary database suddenly got crashed. Yeah, we understood that there is some data loss could be there. So to avoid that kind of situation wherein your data is very much important for you, Oracle has brought in another kind of mode, that is maximum protection mode. So here the maximum protection will be given for your data, and it will ensure that there will be no data loss in case if there is a gap between the primary and standby and all those things. And also you can see here some points on the screen. So it doesn't commit the data until the changes, redo entries, whatever generated in the primary are applied at the standby site. So when we look at the architecture, you will understand this point. And it will cause a slowness on the primary database because the primary database has to wait for the acknowledgement from the standby database. So this is the main difference between the maximum performance mode and protection mode. So here in maximum protection mode, primary database will always wait for an acknowledgement from the standby database, whereas in max performance mode that is not the case. And of course, Oracle recommends to have two standby databases. Now let's look at the architecture, what is happening here. So if you look at the architecture here, we have a primary database and we have the standby database. And in primary database, we have, of course, the background process log writer will be there. So this, we know the general responsibility of log writer is to write into the redo log files. So you can see here step number 2. But before performing step number 2, you can see log writer, the same log writer of the primary database is performing step number 1. And what is the step number 1? Log writer of the primary database is writing the data in the sense redo entries. So log writer of primary database is writing the redo entries into standby redo log files. So if I have a standby created in a different location, then the log writer will over the network, it will pass the redo entries onto the standby side, and on the standby now we have redo log files. In maximum performance architecture, you will not come across this standby redo log files because their entire things will be deal with archives. So, but in max protection mode, we require this standby redo log files to be there. And as you can see, the log writer of the primary database is writing into the standby redo log files. And after once log writer send the information, and once that information has been written into the standby redo log files, then an acknowledgement will be sent back to the log writer. So let's say log writer has passed 100 MB of information, So that 100 MB of information will be first written into this standby redo log files. And after that, it will send an acknowledgement to the log writer that this 100 MB has been completed. Only after receiving that acknowledgement from the standby, then log writer will go for with step 2. So step 2 is nothing but writing into the primary redo log files. So we can say log writer is writing into two redo log files now. One is the standby redo log files and the second one is the primary redo log files. And of course, from the redo log files on the primary side, again archives will be generated. So, and here you can see those archives are not being copied, nothing is happening here. So on the standby, because the log writer has written into redo log files, archiver process will generate archives, and you can see these arrow marks. Whatever the archives that are generated, those archives will be applied to the standby database. So means whatever the changes are happening, those changes will be applied to the standby database, making the standby database in sync with the primary. So this is how the maximum protection mode will work. So basically, the difference comes is the log writer coming into picture, and it is writing into the remote redo log files. So this has been introduced, of course, in 9a itself. So enhancing this a little bit in 10G, Oracle introduced another mode in this maximum protection mode. So which we call it as maximum protection mode real-time apply. So in earlier diagram, if you look at the archives, whatever are generating, those archives on the standby side are getting applied and the standby database is in sync with the primary. But when you come to real-time apply, after log writer writing into standby redo log files, from that standby redo log files itself, directly you are applying the data to the standby database. So you are not waiting for the archives to be generated and you are not applying the archives. Directly from the redo log files itself, you are applying the changes, and this is called as max protection mode with real-time apply. So this is the difference we have.
So Pawan, where I want to understand where the slowness will come here, right? Because it is writing from the log writer, right? Log writer is writing to the standby redo log files, right?
Yeah,
Why this will be slower compared to the maximum? There are three types, right? As you said, maximum performance,
yeah.
and
So
why
the
this is slower compared to this?
yeah, the slowness will come here because of the acknowledgement. So as I said, log writer will first send some 100 MB of data, and that 100 MB of data is being written into the standby redo log files, and assume it takes 2 minutes to write that 100 MB. So till the 2 minutes, log writer will just wait without performing any other activity. So usually what happens, log writer should immediately write into redo log files. But here log writer will not wait, and it will wait for the 2 minutes so that it will get an acknowledgement. So this I'm just taking an example of 100 MB and 2 minutes. Now like if the database is OLTP, so many redo entries will be generated and so much of data need to be written. So in such case, log writer may need to wait some more time. Like if the redo log file size is assuming 500 MB. So writing 500 MB of data, let's say it is taking 6 to 7 minutes of time. So then that 6 to 7 minutes of time log writer need to wait. So obviously if log writer is waiting for some reason, then obviously, DB writer and other process also will slow down. So if one process slow down, automatically other process also will get impacted, and that will be seen at the end user level. So end user, when he performs some transaction, so because this process is there, so instead of taking 4 minutes, the end user transaction may take 5.5 minutes or 6 minutes to complete.
So Pawan, just okay. Let me clarify one more thing. So see, generally, it will be writing to the log buffer, right? Mostly it writes to the log. Suppose there are three log buffers, right? So so it writes, right? So what do you call that? Uh, Context, not context switching. Checkpoint happens, right?
Yeah,
So then it will change, right? From log buffer one to log buffer two, and then three, correct? Cyclic, in a cyclic manner.
right.
So you mean to say, suppose this log writer is taking time to write it to the redo log files,
Hmm.
and from first buffer to second buffer, and from second buffer to third. Now all three buffers are full. So you mean to say there will be a wait event.
No, no.
So
Uh, let me
that is the slowness.
take one example. Okay, so here let's take a situation. This is my primary database, and I have a log writer here. So what we are saying is this log writer will go into the standby side, and we have the standby redo log files here. So yes, as you said, we will have different groups here. So let's say we have three groups in total, and each file size, assume it is as 500 MB. So what happens here? Logwriter will come to over the network. It will come to the standby redo log files, and first it will start writing into this file, first file. So when it is writing into this first file, once it is happening here, then the same logwriter cannot perform writing into the primary redo log files. So when it is performing step number one, obviously it need to wait for some time on step number two, because I mean, just take off this standby. Normally, if you don't have a standby database, then what happens? Logwriter will immediately write into the primary redo log files, right? So there is no wait, or there is no slowness. Immediately, logwriter will keep on writing the information.
Sorry. So let me tell you. So whenever that checkpoint happens, correct? So you
Mhm.
mean to say immediately it will write. When it switches to second log buffer, it will write to the redo log file. That is what you're saying, correct?
Yeah, right.
Oh, so it will write and then only it will move to the next in a cyclical manner.
Yeah, so see here.
Okay.
Logwriter first completed writing into the first redo log file, right? So let's say, as I said, the size is 500 MB, and it has taken 3 minutes to complete it. So till this 3 minutes, these redo log files need to wait for that information. So these redo log files will not get the data immediately, because after completing writing into this redo log file, logwriter should get an acknowledgement that it is successful. So logwriter, once it gets the acknowledgement here, then only it will proceed with step 2, that is writing into the primary redo log files. So for that 3 minutes, the primary redo log files need to wait, and that we call it as the waiting period. So waiting period is there means, obviously it is nothing but the performance issues. So
So
in
there will be a wait event, right, associated with it, correct?
yeah, of course.
Like log file sync and all this. Okay.
Yeah, log file sync wait even would be there. Yeah.
Okay.
Okay, so that is the reason whenever you want to have this maximum protection mode, you need to always ensure that you have a very good and fast network in place. so that these things might be reduced. Like if you have a better network, then there could be a better response time. But again, it all depends on the things. So again, the same thing will repeat, for the next redo log files. Let's say log switch happened, then log writer moved on the standby side, and it is now writing into second one. So until second one completes, here it will not write into the second one. Same way, again a log switch happen until it completes writing into third file. Here it will not write into the third file. So this will continue forever. So that means for every time log writer is writing, there could be some waiting period. Then as I said, log writer when it is slowing down by 3 minutes, obviously the other background process also will slow down by those 3 minutes. So that is why we say there would be a slowness in the architecture. But when comes to real time, it is just a comparison that we are giving between the maximum performance mode and protection mode. But really, you won't see that much impact in the performance because log writer usually will be very fast in writing. So until unless there is bad network, so you won't see the difference in real time. So, when you have your question is resolved?
Yeah, yes, I got it.
Okay. So, yeah, so as I said, the difference between again 9A and 10G is 10G came up with real-time apply option. So, the advantage is the synchronization is much more faster. So, in 9I, the synchronization is happening through archives, as you can see here. But whereas in 10G, the applying will happening directly from the standby redo log files to the standby database. So it is much more faster now. Now here, let's take a scenario. So I have a primary database and I have the log writer. So this log writer is writing into the standby redo log files, and as the first one, then it is writing into the primary redo log files. Now, due to some reason, let's say there is a network disturbance and network got disconnected between primary and the standby database. So what happens in this scenario? So the concept here is maximum protection. And if you remember yesterday, I told you one point that if I have some data in primary, the same data should be available in standby. And if I don't have any data in primary, that data should not be there on the standby as well. So let's say logwriter has logwriter is currently writing into one redo log file on the standby, and when currently it is writing, let's say there is a network disturbance occurred, and the network got disconnected between primary and standby. Now, because logwriter has not got any acknowledgement. So until unless logwriter gets an acknowledgement, it will not continue with the redo log files which are there in the primary. But here we have not got that acknowledgement also because of network disconnection. Then we need to make sure that logwriter should not write into the primary redo log files also. Means if logwriter is not able to write into standby redo log files, then logwriter should not write into the primary redo log files also. Now, okay, if I mean, why it is like that? Why? What if logwriter writes into primary redo log file? If log writer continue writing into primary redo log file, then all of a sudden, let's say the network disturbance occurred at 10 a.m. Then your log writer continued writing into primary redo log file till 10:12 a.m. and at 10:13 a.m. your primary database got crashed. Now, when you try to open the standby database, your standby database is having data only till 10 a.m. So again, there is a data loss. So yesterday, whatever the scenario we talked about, the same thing is repeating here. So if there is a data loss in every mode of working, then obviously clients will not show interest in implementing this data guard concept. So that is the reason what Oracle has made in here is if logwriter is unable to write into the standby redo log files because of network disturbance, then that same logwriter should not write into the primary redo log files also. Now, is there any way to stop the logwriter from writing the redo log files? Means how we can stop a logwriter to write into the primary redo log files. So there is no, direct way. We don't have any command like alter database, logwriter stop, something like that. So what we can do? The only way to stop this is, how we can stop the background process? The only way is to shut down the primary database. Because until unless you shut down, the background process will not stop. So this is what will happen if there is a network disturbance in the max protection mode. So in max protection mode, if logwriter is unable to write into the standby redo log files, then immediately the primary database will go for shutdown because data is important here rather than the availability. You might ask a question here, if primary database goes for a shutdown, what about the users who are connected and who are performing the transaction? Obviously, those users will get error that the database is not available. So but here more than availability, data is important. So if you take an example of a banking environment, so in banking environment, having the data synchronization is more important than users facing issues for just few minutes of time. So that's the reason Oracle designed this particular mode like this, that whenever uh, the data is not able to be in sync in standby database, even in the primary also it should not happen, and your primary database will go for shutdown. So is that clear? Any questions? So that is about the max protection mode. Now obviously this seems to be a bit what you say, not looking not a good kind of architecture because the primary database is going for shutdown. So what Oracle has brought in is it has mixed both the maximum performance mode and maximum protection mode, and it has introduced something called maximum availability mode. So what is max availability mode? So max availability mode will look like this. So it is by default max protection mode only. So this is the third mode that we have. So by default, maximum availability is max protection only. In case something happens, it will turn to max performance mode. So what we will like how it will be. So same thing, the log writer will write into the standby redo log files on the standby. and of course from here directly it will be applied. And from primary, archiver process will generate archeolog files. So this is what will happen here. Now due to some reason, if there is a network disturbance, by default it will be max protection mode as I said. So if there is some difference or network disturbance between primary and standby, immediately it will turn on to max performance mode. And you know, in max performance mode, when there is a network disturbance, here file client will be activated and here file server will be activated. And once the network again re-establishes, then file server and file client will take care of copying these archives onto the standby log files, I mean standby side, and they will start applying the archeolog files to the standby database, making standby database in sync with the primary database. So which means max availability mode by default will work in max protection mode. Only when there is some network disturbance, it will change to max performance mode, and so that file server and file client will be activated. And once when the network got resolved, if there is any archive log gap between primary and standby is there, this file server and file client will take care of that gap. And once again primary and standby is in sync, then file server and file client will go for sleep, and again the max protection mode will start working. So basically you are switching between these two modes of max protection and max performance. So here the name of the mode itself is telling you maximum availability. So here you are looking at maximum availability but not max performance or max protection mode. So that is the third type of mode that we have. So the same things, whatever we have seen, so the same concept is here. Now, depends on the requirement of the client. We might be going for any type of these three modes. So like as I said, if the database is not a very much critical one, in such, or especially if the data is not much critical and it could be regenerated, in such situations we will go for maximum performance mode. And if the data is very much important and you cannot regenerate the data, so in such cases you would be going for maximum protection mode. Then if you feel that availability is much more important than the data, then you can go with maximum availability mode. But when it comes to real time, at least in my experience, what I have seen is people go with the maximum performance mode only most of the times. Like 85% or 90% of the standby database environments, you will be seeing max performance only. And if not, the rest of the 10%, you might see both max protection and max availability. And always Oracle gives us a chance that you can switch between these three modes. So it is not mandatory, or it is nothing like you cannot change the mode. So let's say you are in max performance mode right now and you want to change to max protection. Yes, you can do that. And similarly, you can change from max protection to availability and availability to performance, whatever. So any moment of time you can do that. So that is about three modes of working. So in interviews, whenever they touch the standby database concepts, definitely they will ask you this question: what are the three modes of working and how it is? So you might need to explain the things like what is the primary difference between these three modes. Just give me a moment. Okay. Okay. So Oracle has introduced something called snapshot standby database in 11G. So what exactly is this snapshot standby database is? It is just like an option. So if you have a primary database and have a standby database, as I told you from 10G onwards, you can have your standby database in read-only mode, and in 11G you can have the standby database read-only with apply mode. Means even though your database is in read-only state, still MRP process will work and you can apply the changes. So this is by default called as active data guard. Now Oracle has given you another option that you can temporarily open the standby database in read-write mode. And not only that you can open the database in read-write mode, you can also perform DML and DDL transactions on the standby database. And this we call it as snapshot standby database. The moment you open the standby in read-write mode, we call that as snapshot standby database. And once you complete your activity, let's say you want to test something. So instead of testing it on the primary database or directly implementing on the primary database, you just try to implement that in the standby database by opening it in read-write mode. Then once you are done with this, then again you can shut down the database, shut down the standby, and you can open it like a regular standby database, that is physical standby database. And the moment you again open the database as a physical standby with the read-only option, whatever the changes that you have performed here by executing DML or DDL commands, those changes will be rolled back. That means temporarily you are opening the database in read-write mode, and once you again convert that into physical standby mode, whatever the changes you do when it was there in read-write mode, all those changes will be rolled back, and again it will be in sync with your primary database. So this is the concept of snapshot standby database. Now why Oracle has introduced this concept? So as I said, let's say you have some application release. So generally applications will upgrade by versions like 2.0, 2.1 and all. So let's say you are going for a major release. You are updating your application version from 2.0 to 3.0. And for that, you are doing a lot many table creations, and you are doing so much of action. Now, you tested it in test environment ideally, but usually in real time what happens is test environments configuration, hardware configuration will be a bit less than the production server configuration. Like if production databases servers are having 64 GB of RAM, the test machines may have only 32 GB of RAM. So when you test something on a 32 GB RAM, and when you test the same thing on a 64 GB RAM, the results may vary. So let's say I have a test machine with only 32 GB RAM. I tested my application version 3.0 on that machine. Everything looked fine, but really I don't know how this will behave in production. So to test in production directly, I cannot implement in production. So what Oracle has given the option for you is open this standby database in read write mode and then test, or test in the sense, as I said, whenever version upgrades are happening, so many tables you will be creating and so much of data you will be inserting, or you will be performing some other DML DDL actions. So you can perform all those DML and DDL actions, sorry, on the standby database by converting that into a standby database. So once your testing is done and if you are satisfied with the results, then immediately again you can convert back to physical standby database. And as I said, the moment you do that, whatever the changes you have done will be rolled back. Now because your results are satisfied, now you can implement that change on the production database directly. So which means we are using standby database as the test environment here. So usually primary and standby database servers will have the same configuration. So as we discussed yesterday, even though it is not mandatory to have the same configuration, but usually we maintain the same RAM size, same CPU count, same storage, everything would be same. So that's the reason standby will act as a temporary testing database. So that we call it as snapshot standby. So when from tomorrow we'll be starting with practicals. So after implementing the data guard environment, I will show you how we can convert into snapshot standby. And after the changes, we will do some changes. And once we convert, how those changes will be rolled back. So we will see those things as well. So that was the concept that 11G has introduced. So any questions on that? Okay, so now what's new in 12C? So in 12C, we have the concept called far sync instance. So what is mean by this far sync instance? So to reduce the burden on the primary database, furthermore, Oracle has introduced this far sync instance concept. So the concept is like this. So from the primary database, we are going to ship the things. Ship in the sense we are going to transfer the changes to a environment called far sync instance. And whatever the standby database you have, your standby database will get in sync from this far sync instance rather than directly from the primary database. So just they have introduced a new component here. So instead of directly syncing between primary and standby, now I have one more thing like far sync instance, and primary will write here and standby will take from here. So instead of directly going here, we have an extra step here. Now definitely we will get a question, if we get an extra step here, will it not slow down the synchronization? So Oracle has some answers for it. So you can just go through these points. So the same thing, parsing instance is a remote Oracle data guard destination that accepts the redo from the primary and then it will be applied onto the standby environment. And a parsing instance manages a control file, receives the redo into redo log files and archives so that it can generate a local archive files as well. So which means a parsing instance will have a control file, redo log file and archive files as well. But this point is important. A parsing instance will not have the data files and you cannot open it for even you cannot open it in read only mode because data files itself is not there. So it cannot be open for access, it cannot apply the redo, and it can never act as the primary rule. And it, of course, to implement this, you require a Oracle Active Data Guard license. And if the primary database is failed, then this FARSync instance will take care of performing the failover, like in the sense opening the standby database in open mode, like users can connect to the standby database now. And this can work in only two modes, either max performance mode or max availability mode. So directly max protection is not applicable for FARSync instance. Now you may ask me a question that this doesn't seem to be a great feature. Why Oracle has introduced this? Yes, I mean, seems not to be a great feature uh, because it is just taking some extra step that you are sending the information to some other FARSync instance, and from there again the data is getting replicated to standby. Uh, but this has been a saver when you have a slow response rate in the network. So we have implemented this FARSync instance in one of the environments in my previous assignment. So in my previous assignment, the thing is like my primary database is located in abroad, in one of the cities in United States, and the standby database was located in some other location in Australia. So what we use it to observe all the time is a network slowness between these two things. So what I mean, the thing what after analyzation and all happened is, network admins after their analysis, they have specified that in order to make a better network between these two databases, they have requested us to upgrade the routers both at the primary level and the standby side. So, and the client has, taken a invoice for that. I mean, they have taken an estimation for this, and it seems to be very costly to update the routers both at the primary as well as standby. And moreover, those data centers are not the client owned data centers. So client hired some data center space, and those data center guys, uh, if you pay very high amount only, then they will be upgrading the routers. So for this we have all, and I mean, we analyzed what could be other possible things, and we identified, like after discussing with the data center guys, we identified that there are some more databases which are hosted in UK, and those the network between those databases to the standby databases which are hosted in Australia, so it is pretty good, it is happening pretty good. So then we came with a solution that we have this primary database in United States, and we have created this FARSync instance in UK. So I mean, our client has purchased some data center space in UK. So, and we have created a FARSync instance there. So network between this primary and this FARSync is good. So the replication is happening faster. And as I said, UK to Australia also network is good. So that is also happening faster. So this is one scenario in my experience where we have implemented this far sync instance. And also this far sync instance will help you in case if you have a multiple standby databases. Let's say you have three standby databases. Your client is maintaining three standby databases. Then instead of primary database pushing directly the data into three standby databases, you can just have this far sync instance. So your standby databases will always get the data from this far sync instance without disturbing your primary database. So these are some examples where you can use the far sync instance. So any questions on this? Okay, so next we have two terminologies to understand in this data guard environment. So one we call it as switchover, and the second one we call it as failover. Now what exactly is mean by switchover? Let's say my client asked me to create a standby database to configure a new standby database, and I just completed it. But how I am sure that this standby database is going to work in case if something happens to the primary database? So we need to test it. So to test it, we will be changing the roles of the databases. So we will make primary database as the standby database, and we will make the standby database as primary database uh, by taking some planned outage. So not much time is required. Within few minutes this will be done. So maybe let's say 5 minutes, 10 minutes, or 15 minutes maximum. So this activity, because we are planning and doing it, we call this activity as a switchover activity. So wantedly you want to test it, so you will be changing the roles of the primary and standby. So there in the picture you can see, before switchover, we have site 1 and site 2. Site 1 is acting as a primary database and site 2 is acting as standby. Whereas after switchover, site 1 will become physical standby and site 2 will become the primary database. And in real sorry, so in real time, for every 6 months or 3 months, usually this testing will happen. So for example, in our environment, so it happens like every 6 months we will change the rules. So first 6 months, generally we do every February and every October. So this is the time that we have. So every February we will be making one as one data center databases as primary, and we will be switching them on February. So the rest of the 6 months, the other data center databases like the standby databases will now become primary, and then October again we will do a switchover. So this is just to ensure that applications are working fine without any disturbance. So then we have failover, which is an unplanned activity or a sudden occurrence. So everything is going fine and all of a sudden your primary database is crashed, then obviously your users should be diverted to the standby database. And that scenario is called as failover activity. So in failover activity, once your primary database is crashed because of some reason, then you will be opening the standby database for user access. Now here only you have two options. Whenever there is a primary database crash, either you can manually open the standby database by using some commands, or you can automatically open the standby database. So when you do that automatic configuration, we call that as automatic failover. So manually means you need to know that primary database is down, and then you need to open the standby database with the help of some commands. So that would take some time, like maybe 10 minutes or something like that. So even if you cannot pair that 5 minutes or 10 minutes of connectivity things, availability things, then you might go for this automatic failover. So what we do in automatic failover, so instead of calling it as automatic failover, we call that as fast start failover. So in fast start failover, we are going to configure something called observer. So here you can see the diagram. So we have a third component called observer, which will always keep monitoring both your primary database and standby database. And if due to some reason, if the primary database is not available, then immediately observer will open the standby database as the primary database. So what observer will basically will do is it will do a ping to the servers for every 3 seconds. So every 3 seconds it will do a ping and TNS ping. So ping to the server and TNS ping to the database. So if it has not got any response, then observer will retry. Like for by default for 10 times it will retry. So 10 times in the sense 30 seconds. Because as I said, for every 3 seconds it will give a try. So for next 30 seconds it will give a try. And even after 30 seconds it is not getting any response from the primary, then immediately without asking any permission it will open the standby database. So that is what we have in fast start failover. So I have not seen most of the environments implemented this. People still prefer to go with the manual method because of easiness and all. And one more thing is this observer need to be run in third machine. You cannot have observer running in primary or standby database. It need to be executed in third machine. So again, because of those things that you need to maintain another machine and always observer need to be up and running and all. Many of the environments don't have this concept of fast start failover. So anyway, in our practicals, we'll be seeing it. We may not see fast start failover, but we'll be seeing how to configure observer and how to make observer up and running. So we will see those things. Of course, we have seen data guard benefits, so nothing much to discuss. Now, when it comes to 12C, as I told you, fast sync instance is there already. Apart from that, what are all the other enhancements we have? So we have been introduced with a new administrative role called sysdg. Earlier, we used to work with sysdba, which is our regular role which we use. But instead of that, for data guard environment, now we have an exclusive role called sysdg. And redo can be cascaded in real time, called real-time cascading, and need license of active data guard. So, which means, I mean, same thing, the point we discussed. So, from the redo log files itself, the data can be directly applied to the standby redo log files. And parsing instance, we just saw about that. And supported by online data file movement. So we can move the data file online in 12C database in a regular database. So this is supported even in the standby database. So if you want to move a data file in the standby database without shutting down the database, you can do it online. And earlier, when we use it to enable real-time apply, we use it to give a command called using current log file. Now you don't require to use that clause anymore. So that clause is removed directly. When we look at the commands, I will show you. So directly we can use a simple command to start real-time apply. And also switchover and failover has made simple now. So when we discuss about that switchover and failover commands, I will tell you the difference between 12c and 11g. In 11g we use it to have so many commands, whereas in 12c we have just only a single line command. And coming with the 12c release 2 data guard features, uh, Oracle has introduced a multiple observers advantage. So till now you can create only one observer, that too in a third machine as I said, but 12c release 2 will give the advantage of going with multiple observers. And you can enable fast start failover in max protection mode. So fast start failover use it to work only in max performance and max availability mode. Now it is supporting in max protection mode as well. And automatic password file synchronization. So whenever you have this primary database and standby database, you know password files will be there. So if you change your sys password in primary, then it will, I mean, your standby database will stop working. If primary and standby are not having the same sys password, then synchronization will not happen. Many times what will happen is we will change the password in the primary, but we will forget to change in the standby database. So, this has been a problem. So what Oracle has done in 12c release 2, even if you change the password of sys user in primary, automatically that password will get updated in the standby without any extra things that you need to do. Or otherwise earlier we use it to copy the password file from primaries to standby, and again we use it to make that password in synchronization. And now we can have AWR and ADDM reports for the standby database also, but these reports you can generate from the primary database itself. So the reports are for standby, but they will store in the primary itself. So if you feel that standby is slow, I mean it is not responding fast, or it is applying the archive slowly and all, you want to see what exactly is the performance issue, then you can generate these AWR and ADDM reports. So those are the some of the new features we have in 12c release 2. So that is all about the theoretical concepts what we have with the standby database. So tomorrow we will be seeing how to configure the standby database, and it is exactly same as cloning. So we have seen Harman cloning already. So we are going to follow the same steps of Harman cloning. Only difference comes is the last command that we use in Harman. So if you remember, we have used a command like duplicate target database to so and so. There is one command like that. So instead of that command, we use something like duplicate target database for standby. So simply by using that command, uh, Arman itself will do, or Oracle itself will do the cloning, and it will make it as a standby database. So most of the steps are cloning related steps only, but only few steps initially are there, wherein we are going to set some parameters on the primary database. So apart from those steps, everything will be similar to cloning. So if possible, you people can just practice Arman cloning once again today, so that when I'm showing the steps tomorrow, it will be familiar with you. So anyone having questions? Okay, so that is all we have for today. So let's meet tomorrow at the same time.
Pawan, this is Sachin here.
Yes, Sachin.
About Friday's video. I requested yesterday.
Oh, okay. I'll just share it now.
Okay, thanks.
Okay, so let's meet tomorrow at the same time. Have a nice day.